So like I had mentioned in the last video, we don't have an instrument that can measure how much heat a substance has. So we can take different measurements and put them into these formulas and we can calculate how much heat something has. So before we talk about what the formulas are, we need to talk about what heat of fusion and heat of vaporization are. So fusion is another word for melting. So heat of fusion is going to be how much heat is required to melt 1 gram of a sample at its melting point, where heat of vaporization is how much heat is required to vaporize or boil 1 gram of a substance at its boiling point. Okay, so those numbers are standard numbers, and if you are taking the Regents, you're going to be allowed to use your reference tables, and the heat of fusion and heat of vaporization for water are given to you there. For honors, you do have to memorize those numbers for water, and you have to memorize them in 2 different units. Okay, so the abbreviation for heat of fusion is HF, and the heat of fusion for water is 334 joules per gram or 80 calories per gram. So energy can be measured in joules or calories, and you have to pay attention to what the question is asking for or what the other units in the question are to decide which heat of fusion is appropriate to pick. Okay, the abbreviation for heat of vaporization is HV. And again, for water, you have to know these two values. In joules, it takes 2,260 joules of heat to boil 1 gram of water. That's what that means, joules per gram, or 540 calories to boil 1 gram of water. Okay, so HF and HV are going to pop up in these formulas that we talk about next. Specific heat is also going to pop up. So when a phase is changing, the temperature is not changing. So heat of fusion and heat of vaporization will be important numbers for when we're looking at a phase change. When temperature changes, we have to look at the specific heat of the substance, which is how much heat is required to change the temperature of 1 gram of a substance by 1 degree Celsius. Okay, because temperature can only change when the phase is not changing. So it's all different formulas. The specific heat symbol is C. And just like the others, guys, you have to remember what the specific heat of water is in all different units. So it's 4.18 if we're looking at joules. Or if the question is asking for calories, we can use the number 1 to represent specific heat for water. And all different substances have different specific heats and heats of fusions and heats of vaporization. So if the question is not about water, they would have to give you these values. Something important to notice here, guys, because you will have to convert between joules and calories sometimes. If you look at specific heat, we can see that 4.18 joules is equal to 1 calorie. So you can use that as a conversion factor later on if you have to change your units for some reason. Okay, so let's connect all of this information to our heating curves. If I'm not changing phases, I'm talking about these 3 areas where I have my solid and my liquid and my gas. And what they all have in common is that they're in a single phase, and as I add heat, the temperature is going up. So if you want to calculate how much heat is being added, you have to use the formula Q, and Q is the abbreviation for heat. And you have to do MC delta T. So you have to take the mass of the substance, multiply it by its specific heat, and then change in temperature, delta T, is the final temperature of the substance minus the initial temperature of the substance. Okay, so anytime you're talking about any of those three parts on this graph, that's the formula you use. If they don't give you a graph to look at, the question is going to have two temperatures in it, and that's how you'll know the phase is not changing, that the temperature is going up. Okay, again, guys, this formula is on the chemistry reference tables. You can use it when you're taking the Regents, but for our class and our quizzes and tests, this is a formula that you're going to have to memorize. Okay. When the phase changes, so here and here, my temperature is not changing. So if I were to use that MC delta T formula, if my delta T is 0, then when I multiply that by mass and specific heat, I'm going to get 0 as the amount of heat absorbed, which doesn't make any sense because if my substance is melting or boiling, I know that there must be heat being added. So we can't use that formula to talk about a phase change. The other two formulas that we need to memorize, they're different actually for melting and boiling. For melting, Q equals mass times HF. So heat of fusion is that value we talked about a little while ago. For water, it's 334. And for vaporization, you would use the formula Q equals mHV. So again, M is the mass and HV is that constant that's given to you. For water, it's 2260. For a different substance, they would have to give you that information. Okay, so first problem is to pick the right formula. And then you have to make sure you plug your numbers in the right spots and make sure all of your units cancel out. Okay, so let's look at some practice questions together. At this point, guys, if you haven't taken out a calculator, you should take one out and just make sure you're calculating along with me. Okay, so if I look at question number 1, how much water can be heated from 2 degrees Celsius to 50 degrees Celsius? So is there a phase change or is my temperature changing? If they give me two temperatures, that means my temperature is changing. So I know the formula that I should pick is Q equals MC delta T. Okay. Now I need to go in and plug in what I'm given. So for this question, I'm given 3,000 joules. So they're actually telling me how much heat I have being added. They're not giving me a mass. That's what they're asking me to solve for, how much water. So M is going to be my unknown. If the heat is in joules, I have to plug in the specific heat that has joules with it so that my joules end up canceling out at the end. If the heat was in calories, I would use the number 1 here instead. And then for temperature, 50 minus 2 is 48.0 degrees Celsius. So guys, we're not going to be crazy with sig figs in the rest of the units. We really just were focusing on them in the first measurement unit. But just to review, when I'm subtracting two numbers, I want to look at the number of numbers after the decimal place. So 2.0 has one number after the decimal place, and 50.0 has one number after the decimal place. So when I subtract those two numbers, I want to round my answer so that it has one number after the decimal place. Okay? Now the rest of my math here is going to be multiplying and dividing. So I'm just going to change the color so you can see this better. So if I look at my numbers here, 3,000 has 4 sig figs in it, 4.18. Well, for constants, you can kind of ignore constants. So don't worry about the 4.18. 48.0, which is the temperature, has 3 sig figs in it. So my final answer, I want to round it to the smallest number of sig figs, which should be 3. But we'll get to that in a minute. So in your calculators, I want you to do 3,000 divided by, now 4.18 times 48 should be in parentheses so that you're making sure your calculator does that multiplication first before it divides. Okay, plug that in there, and hopefully we all got 14.9. Now, guys, you can either think like, okay, I solved for mass. The units for mass are grams, or you can go through and cross out. Joules cancels out joules. Degrees Celsius cancels out degrees Celsius. The only unit I have left in here is grams. So that would be the unit for my answer. And 14.9 has 3 sig figs. Make sense? All right, let's look at question number 2. I'm heating 22 grams of water from 10 to 30 degrees Celsius. Okay, so again, guys, if I have 2 temperatures, we should know what formula to pick. So I'm going to let a question pop up here. I'm going to let you guys try this on your own. Okay, now that you're back, we should have picked the MCAT formula. This time we're solving for Q. Mass is 22.0 grams. It doesn't tell us. Oh, it does tell us. It tells us to solve for energy in joules. So I want to pick the specific heat that has joules in it. Otherwise, if you solve in calories, then you just have to worry about converting your answer, which you don't want to do. But you can if you want. And the change in temperature is 20. When I do 30 minus 10, I get 20. And if I put that in my calculator and multiply, I get 1839.2 joules. If I'm rounding that to 3 sig figs, I would run around this to 1840, no decimal point, joules. Okay. Question 3, how much energy is required to melt 10 grams of ice at 0 degrees Celsius? So once I know there's a phase change, I know I can't use that delta T formula. Also, guys, they're only giving me one temperature. So if I only have one temperature and there's nothing to subtract, I can't use that formula. So my formula for melting is MHF. Okay, so they're giving me the mass, which is 10 grams. Heat of fusion is one of those constants that you have to memorize. So for water, it's 334 joules per gram. This question doesn't actually specify a unit. Joules is the only unit they use on the chemistry region. So if it doesn't specify, I usually just go straight to joules. If you wanted to do calories, that wouldn't be wrong because it doesn't specify it, like I said. But when we cross out our units and we multiply these numbers, I'm going to get 3340 and joules. And the number 10 has 3 sig figs in it. So my answer should also have 3 sig figs in it, which it does because that 0 does not count when there's no decimal at the end. Okay. Last formula, guys. This is the only one that's going to be different. This time they're telling us that my water is boiling. Okay, so boiling means it's a phase change, and I need to use this formula because I don't have 2 temperatures. So my mass is 10 grams. Heat of vaporization, again, that's a number you have to memorize. They don't specify a unit, so I'm going to go with joules. You can go with calories too, it doesn't matter. And when you put this in your calculator, you get that. Okay. Look that they're giving us a temperature here too, guys. 100 degrees Celsius is the boiling point of water. 0 degrees Celsius is the melting point of water. In these 2 questions, the temperature is excess information. What they would love for you to do by mistake is take that 100 and plug it in for HV. If this was multiple choice, that would probably be one of the answer choices because they expect you to do that wrong. So anytime it's a phase change and they give you a temperature, just remember that that's extra information. Okay, now this is a tricky one for sig figs because if I look at this mass, there's no decimal in it. So the number 10 here only has one sig fig, which means I need to round my answer so that there's only one sig fig. So I would round this down to 20,000 joules. Or I can put it in scientific notation. Okay, so any of those would be acceptable answers for number 4. Okay, 5 and 6 get a little bit more complicated. So I want you guys to read question 5 and think about what formula would make most sense to use. Right away, I see that I'm only given one temperature, but they're asking me what the final temperature is. So they're telling me that the temperature has changed. So even though I don't see 2 temperatures in here, I know I have to use the MC delta T formula because the temperature must be changing for there to be a different final temperature. So again, we're just going to go and plug in what we're given. So heat is 150 joules. Mass is 20 grams. Specific heat, if the heat is in joules, the specific heat needs to be in joules. Okay, now delta T, when you subtract those two numbers, you should be doing final minus initial. So the final temperature is what I don't know, and I'm going to minus the initial. Okay, if you put those numbers in backwards, you're going to make, so here heat was being added, my final temperature should be higher than 30. If you flip around your subtraction, the final answer that you would get for temperature would be lower than 30. So that wouldn't really work out. So just make sure you do it that way. Okay, so the first thing I like to do for this, I like to just rewrite it where I multiply the 20 times the 4.18 and I get 83.6. And when I do that, I'm getting rid of the grams. One's on top and one's on bottom. So right now my units are just joules per degree Celsius. Final temperature minus initial temperature. Okay. So now I want to get rid of this 83.6. I want to divide both sides by 83.6 to get rid of it. So if you do in your calculators 150 divided by 83.6, you should get 1.8 degrees Celsius, because now my joules are canceling out, equals T final minus 30. Now, if you're wondering why I rounded to 1.8, 83.6 has 3 sig figs in it, but 150 only has 2. So I always want to round to the lowest number of sig figs. Okay. So now I want to get T final by itself. So I'm going to add 30 to both sides. And I'm going to get 31.8 degrees Celsius as my final temperature. And now, since this was an addition, my rules for sig figs are looking at how many numbers are past the decimal place. So both of those numbers have a number in the 10th spot. So my final answer has to have a number in the 10th spot. So we rounded that correctly, and we can leave that answer as is. Okay. So as far as MC delta T goes, final temperature is the trickiest to solve for. It has the most steps as far as algebra goes. I would take the time to write them out just to make sure you don't make any silly mistakes. Okay. All right, guys, last question. This is what separates honors from regents, this type of question. And I will tell you why. So first of all, I see that the question is asking me for calories. So, so you want to use the other constants for your formulas, the ones that have calories in them. So they're telling me I want to vaporize 20 grams of water. So right away I would say, okay, MHV, nice and easy. But now they're telling me that my water is starting off at negative 15 degrees Celsius. So what phase is water in at negative 15 degrees Celsius? It's frozen, it's solid. So to get to vaporization, I have to take that solid. Let's draw a little diagram here. I have to take that solid, I have to add heat to it, I have to melt it, I have to turn it into a liquid, and then get it hot enough to start boiling. So anytime you're going through multiple different sections on a heating curve or a cooling curve, you need to use multiple different formulas to solve. So I started at negative 15 degrees Celsius. It melts at 0 degrees Celsius and it boils at 100 degrees Celsius. So I have to do, let's use a different color. I have to do 1, 2, 3, 4 different formulas to get how much heat is required to get through this whole process. So this is going to be really long, so start on the left side of your paper. Let's look at number 1. During this section in number 1, my temperature is increasing, so I'm going to use MCAT. During section 2, I'm melting, so I'm going to use MHF. During section 3, my temperature is changing again, so another MCAT. During section 4, I'm boiling or vaporizing. So I have to use all those formulas and add together all 4 of those sections. I strongly recommend when you get a question like this that you draw a heating curve like I did. This way you're making sure you're not forgetting anything. Okay? So for the sake of simplicity, guys, I'm not going to worry about sig figs here. We're just going to make sure we're plugging in the right numbers. So I have 20 grams of water, right? So M is always going to equal 20. And they're asking about calories. So the specific heat of, see, this is another thing you have to be careful. See how they're giving me extra information here? The specific heat for water in the liquid phase is 1 calorie per gram, but specific heat of ice and the specific heat of gas are actually different. So you also have to pay attention to what phase the question is talking about. And if they're giving you a different phase that's not the liquid phase, they're going to have to give you those different specific heats. So here I actually want to plug in 0.5. Okay, because they're giving me that. That's the specific heat of ice. Now, delta T, I want to look at my graph. So final minus initial. I'm going from, I ended up at 0 degrees Celsius from negative 15. So my final was 0. My initial was negative 15. All right. Now, melting. M is 20. HF in calories is, let me scroll back up. Did I write that down in your notes before? Yeah, so we have to use the HF in calories, which is 80 for water. So we're not going to plug in that 334 number. All right, another mass, 20. Now, guys, for this part of the graph, water is in the liquid phase. We're talking about section 3 here. Let me number this so that we see what I'm talking about. So these numbers match up with my graph. Okay, so now that I'm in the liquid phase, I can use the specific heat of 1. And again, I'm not using 4.18 because I don't want joules. Delta T, the final temperature of that section was 100, and the initial temperature for that section was 0. And my last phase, I have 20, and heat of vaporization, it would be 2260 for joules, but 540 for calories. Okay, so let's just go through and at least do the subtractions first. So this was a 15-degree change, 20 times 80, 20 times 1 times 100, and then 20 times 540. Okay, and guys, similar to conversions and all the math we did in the last unit, questions like these are going to be worth a lot of points. So the more work you show, the more points I can try to give you if your answer isn't correct, because I can at least see what you did and find a mistake and then give you credit for the rest. Okay, so you want to make sure that you show your work at all times. All right, so I'm going to take my calculator out. You should too. If I do 20 times 0.5 times 15, I get 150 plus 20 times 80, 1600 plus 20 times 1 times 100 is 2000 plus 20 times 540. 10,800. So if I take all of those numbers and I add them up, that's 1,600 plus 150. You guys should all be doing this too, just to make sure. 14,550 calories. Okay, so I'm going to give you guys some practice problems, and we'll talk more about this when we get to class tomorrow.